Hello everyone, welcome to Chinese Sunday. Today we are going to discuss about the AI breakthroughs that will blow your mind in 2025. So, the first one we are going to discuss about engineering environmental legislative guided LLM to support the waste management learning. So, we'll start the existing challenges in waste management. First of all, the waste laws are very complex, and most of the people don't understand them, even if few will follow them. And at the same time, the recycling stays inefficient. So, how are you going to solve this problem? Is what this paper discusses about. So, they are presenting the WasteGenie, an engineering environmental legislative guide LLM. What does it do? So, here we are in this AI-driven learning framework. We are using WasteGenie Plus to transform complicated waste laws into fun learning games, all verified by AI. We are using GPT-4 converting legal rules into interactive quizzes and sorting challenges anyone can enjoy. At the same time, we are using G-Eval, which is produced by Google and IBM for double checking the facts and also providing the correct LLM. So what is this G-Eval? So G-Eval is an AI model that works like a smart reviewer, which will review everything the ChatGPT-4 creates. So we will get to know whether all the facts are factually correct or not, which means it provides the information, the indicators which are coherence, preservation, informativeness, and readability. So, what are the AI features provided in the WasteGenie Plus? So, they are having AI that learns laws, which will create short, clear posts explaining the complex rules, and it also has environmental quizzes, which will let you know about more recycling knowledges. At the same time, we have smart questions, which are like regular updates, which will be shown in multiple MCQs as given in the pictures. At last, they also have sorting games, which will teach them which correct bin to instant feedback when mistakes are made. Yeah, and what are the results and impact found? During the research, it is known that it has increased the accuracy from 86% to 94% after using WasteGenie Plus. So the people are getting to know more about the recycling accuracy. Continuing our AI breakthrough series with the next one, which is an Agent Pulse, a voice-based AI doctor. So this is a paper produced in used by IBM and Morehouse School of Medicine. So this is a voice-based AI agent, which filling the economic gaps in digital health delivery. So, what are the gaps in healthcare we are facing? First of all, doctors overload. Too many patients are there, which the doctors can't go and reach each and every one. At the same time, it's very high cost. So the medical care and consultations are too high. With the missed follow-ups, many patients don't get the regular updates. And the rural challenges. Many rural people cannot have the basic needs. So here what is the graph it shows is, as you can see, the red color when the severity is very high and the doctors are needed. But when the severity is lowered, the doctors are not needed and the nurses are will be taking care of you. After this, the family and friends will take care. But there is some point, like the blue color, where no one will be taking care. So that is where we are going to see the Agent Pulse is going to do. Because as you can see, many in few cases, again after going to that place, due to not following the health regulations, the graph is again getting too high. So how are you going to tackle these kind of problems is what the project is about. So imagine a doctor which listens to your health through simple voice chats, no apps or form, just talk. And it will monitor your health and alerts the doctor when needed and brings the healthware to everyone and anywhere. This is what the Agent Pulse is about. It is a voice-based AI assistant which is designed to make healthcare more accessible and efficient using advanced technology to connect the doctors and patients. So how does it work? In this concept, there's no need of apps or anything. It's just a simple phone call by which the patient can talk with the Agent Pulse and get to know what are the health issues. At the same time, this Agent Pulse is using an AI, uses the Watson's AI, which is provided by IBM to understand questions and reference the medical knowledge. So they are using Solomon, which will manage the conversations and it will be creating and assessing responses. So this will help to make a dashboard for physicians also, who can view and see what are the problem. The right side image shows the clear diagram. So, what is the real world pilot study? A study happened in MSM where it is known that the nurses are getting constantly burnt out due to many follow-up calls, by which they are getting very exhausted. So, and also the group sessions are creating some privacy concerns in there. So, to solve these problems, they have been given the agent pulse. So, due to which the privacy problem is totally eradicated. At the same time, it also gives consistent, judgment-free care anytime. So, as you can see the graph, 37% of the people have the plus point on using the voice agent, whereas 24% still are only suggesting the group calls, which they like, and 15% like either, and 18% like both. So results and benefits: by this voice-based AI, it will fill the healthcare gaps efficiently and affordably. So the workload for nurses will be reduced tremendously, and the patient's privacy will also be maintained. So 70% of the patients found it very comfortable to use this AI system, and it also frees a doctor, and they can focus on more critical cases, while the AI will manage the routine care. But this product still has technical challenges, which are efficient conversation management, and the infrastructure optimization is way too high. At the same time, personalization and adaptation for each and every patient will take more time and more data, and still there are more and more data to feed. So RAG, which is retrieval augmented generation, is too hard for this. So this is a project on Pulse AI, which is provided by IBM and Morehouse School of Medicine. Hi. So this is a continuation of the AI projects of 2025. So after having covering the topics like Pulse, Agent, and WasteGenie, the next we are going to see about RL, that is reinforcement learning based stock trading bots. So this is a project presented in San Jose State University and National Technical University of Athens. So this is to paper produced in 2025 IEEE, learning to play the trading game, exploring reinforcement learning based on stock trading bots. Yeah. So coming to our topic, what is the main problem we are facing? The problem faced is traditional trading bots, they only depend on predictions, and they cannot adapt to the market quickly due to the emotional and volatile markets confusing their logic. At the same time, this leads to unstable, inconsistent, and unreliable results producing. To overcome this, we are using reinforcement learning. Reinforcement learning is where the system will be constantly adapting to the strategies, like mimicking the human cognitive process. So here it will first experience through reward-based interaction with the environment, where it will know whether it should be correct to do a particular thing or not. If it's correct, means it gets rewarded, otherwise it will get a punishment. So this is how the system adapts, and it has intelligence. At the same time, it improves. It constantly keeps on evolving through performance and practices. Yeah, this is the system. Inside the AI, in this trading bot, what they did is they are using deep Q learning, where it will train the AI to choose the best action, whether to sell a stock or hold it or buy it for long-term rewards. And also it uses 30-day stock to for 4 layers of neural network, where it will be constantly practicing. So it will also depends on policy gradients, which is used to refine their trading strategies through reward feedback loops. That will improve their performance for profit and more reducing the risk. So it's also a self-learning trader. What is the training data? Training data they produced are like 10 years of historical data in S&P, Google, and Apple. By this, it will know to learn the various patterns and react to the market volatility. So by this, from a random to it becomes a very smart trading bot. So using this, it will be more highly intelligent trader, demonstrating consistent improvements and strategic decision making. Yeah. So finally, it is known that 18% of the profit has been increased using the system, and also 95% of the consistency rate is improved. So yeah, this is a complete project, but still there are some technical challenges faced. One is trading a flexible reinforcement learning trading will be very challenging and unstable, and also there are many strategies which will be produced, so it will not lead to any consistent result. At the same time, the deep queue need precise turning and a well-balanced reward function, otherwise it will keep on fluctuating. And at the same time, there are also other problems like it cannot it has real world limits like capital constraints or volatile data, which is very hard to learn. At the same time, it struggles with multiple data and real time markets, which will be a bit of an issue. But overall, with improvement of reliability and scalability, it will be a very useful thing to do. Yeah, thank you. The fourth project which you're going to see is the rise of LLM-based AI agents. What is about? The development of AI agent based on LLM platforms is a paper published in the AI conference in 2025 by the School of Computer Science in Zhengzhou University of Aeronautics. So, what is this paper about? First, we'll just have a general discussion between what is a rule-based AI and adaptive agents. So, rule-based AI should follow is a traditional AI which follows a strict preset rules with no flexibility. They cannot adapt or learn new information, and it's very ineffective in unpredictable situations. Whereas adaptive agents, on the other hand, they can learn and adapt from their experiences. They make context-based decisions instead of following fixed rules. This gives them a far stronger problem solving and reasonable abilities. So what is the core architecture of an AI agent? So at the backbone is the LLM, which serves as an intelligent backbone for the agents. And from here it links to different tools and APIs by which it will seamlessly connect with external resources. And everything is autonomous. It's a self-operating system and it doesn't need anyone to stop or do anything extra. It just autonomously does the whole work. So some AI platforms which are known for now is Cause, Agent Builder, Tencent Yuanq, DeFi, Zifu Qingyan, and Microsoft Copilot, OpenAI API, FastGPT. So each have their own advantages and applications. So first, how are they building an agent? So what is the plan to building an AI agent? The first is to have a plan, that is having the requirement analysis of what the agent is going to do. And second part of plan is using a configure an AI agent. So based on this, we'll build the AI agent, and at last about the testing and deployment. So yeah, they have conducted a case study in Course Assistant Insights. So they have created a Course Assistant agent using the general agent building procedure. And what are they doing? At first, they have a requirement analysis where they give the user input, which is processed by the LLM agents using prompts. So yeah, this in the right side, this shows how the agent is built. First, they usually give the idea, and the agent will be making the course plan and creates the contents and suggests some teaching resources. And at last, it reviews from the web search, which is in tools. So this LLM has help from different API and tools by which it will review, and at last it will improve and finally show the final output. So this is a requirement. So how are they building this? So we will create an AI. They have created an AI project in Cause, and it takes like a course creation or QA, and pick the models like GPT or BERT which you use depending on the goal. And for this, you link to different APIs and knowledge bases for smart auctions. At last, use the strong prompts to define the agent's behavior and improve the accuracy. At right, you can see a general prompt, which is a very strong prompt, which they used for the agent's behavior to improve the accuracy. So, after this, but still there are many challenges in developing the AI agent. First one is the high cost for the development expenses can be significant for the generating an AI agent. And human reliance, it's still put human input for the prompts, which remains a major challenge. Apart from this, stability issue is also there. There are frequent bugs and glitches which will affect the overall performance. And in the future, how are we going to see the AI agents? Through vision, voice, and reasoning. So these are how the future AI agents are going to work. Yeah, so this is the whole complete. So hello everyone, this is the final paper of the part 1 series in mind-blowing AI technologies 2025. So here what you are going to see is smarter EV charging with AI agents, and this is one of the good papers I have viewed till now. It's an EV charging system considering power dispatching based on multi-agent LLMs and CGAN. So what is the problem here is when generally people power in the power station, sometimes the power gets too much heavy load and many fluctuations occur. So to avoid these kind of things, and also sometimes the power station costs cheaper compared to other times due to the high no supply or high supply. So depending on this, we are going to solve the problem to make the users more efficiently use the power station. So the core idea is we are using a dual agent framework for EV charging. Here we had two agents. One is a user agent, which will interact with the EV customers and gather their preferences, their personal charging solutions, and will make plans to enhance the user satisfaction. At the same time, we also have EVCS agent, which is the managed charging stations that will see when will be the optimized pricing and when it's available real time. It will take information about the power grid and make the overall utilization good. So how this multi-agent system works is, first a user suggestion. As on the right side you can see, it will just view what are the user, where they're going, the navigation, and their performance and memory. So preference and memory. Based on all this user data, LLM is trained, and this will negotiate with the EVCS agent. So this is the EVCS agent, which will also have data like what are the people who are coming, historical data, what is the current status, and time LLM, how much time each and everything. And based on this, another LLM is trained. So these two are going to negotiate in this negotiation platform, where they will see whether to adjust the platform, or adjust the time, or when to come to the EV station, or when to get the supply, etc. So what is the user agent? The user agent helps the EV drivers to find the best charging station. It will gather the map, time, weather to understand this situation, and it will use the rack to re-rank all the informations on which is the first preference EV station compared to others. And finally, the LLM model will get a personalized charging recommendation in real time. At the same time, there is the EVCS agent, which is the agent of the charging station, which will, based on the historical data, will re-rank the station's rank and see which is the nearby people who will be coming and visiting the places, and it will help in predicting the future load demand also using the time LLM. And these two will be communicating in the negotiation platform. This negotiation platform is where the user agent and EVCS agents connect and will having ranking options based on the user preferences. So it enables the dynamic privacy protect discussion where the agents negotiate and will agree on the best charging price in real time. Here you can see the template. Based on this, how the agents will the user agent will give the idea, and based on this it will suggest which one to look. And also the main thing is, there are not many data available for training the agents. So that's why we are going to generate some data using the CGAN, which will generate the realistic training data, which will be useful for the training the system. So further, the LLM enhances semantic accuracy. As you can see, left side, so I can show you. So this is a simulation done to research more about the agents, about this EV agent. So to know it, they have 100 simulated EV users placed in 6 km radius in Shanghai, as you can see in the right side, and each one have different preferences, the states of charges, etc. And the charging prices are dynamically set between 0.8 to 1.2 and base rates. So some noises are also added in the data to test the robustness of the model. So what are the results? As you can see from this table and the results, the selection is the fast charging options. Like here it is a tilt, which is the first when the speed is preferred, while the slower stations like AV is for slower charging. So based on this, the systems will communicate, and based on the user preferences, it will suggest which one is the more compatible one. So yeah, this is how the choice. Meanwhile, some weather conditions are also further refined these choices. Based on sunny day, it is better to power the near station compared to other days when it's cloudy days where it is farther, like these kind of things. So what are negotiations with different LLMs? So they also use different LLM negotiation platforms to check which one is the better. So as you can see, both are giving somewhat similar, but GPT-4 offers a lower price strategy, whereas DeepSeek adjusts the prices and will not just aim for the lowest price, but will carefully adjust the prices. So these model prioritizes user preferences and situation status differently, so which gives different results. And how in the future they are going to enhance this? The future research directions are, first was the investigate more comprehensive data, so based on travel platform patterns, the energy policies, etc. At the same time, the long-term impact of the charging behaviors is also noted, like dynamic pricing subsistence or mobility shift. And the economic and social factors also influence based on the community. And for the LLM itself, they have scale to affect their performance and resource for compensation. So yeah, this is the complete project on EV station.